Okay, today's topic in Algebra 1 is called geometric solids. And actually with this here, we're going to revisit what we've already talked about, which is called volume. Now remember, volume is equal to the area of the base times the height. And when we found volume before, for example, maybe we've got a box-shaped object, I should say. And volume is how much that box would hold. That's volume. And we would find the area of the base, so we would find the area of the bottom of this, this box, which in this case, it's either a rectangle or a square, and we take length times width. And we find the area of that, and then we take it times the height of the box. And that's volume. Now let's get to what we mean by geometric solids. Now in example 1 here, you don't need to write down the whole word problem, but I do want you to write down how we do the problem. Now let's read this. It says the area of the base of a right pentagonal prism is 34 inches or square inches, and the length of the lateral edge is 12 inches. Find the volume. Now the only difference with what we're talking about with geometric solids and what we've had before is the object that's shown in example 1 is a geometric solid. So in other words, we're not just typically talking about the bottom being a rectangle or a square. Now we've got, if you take a close look at the bottom of this figure, looks like we've got a 1, 2, 3, 4, 5. Here we have a pentagon. So you're going to have different shapes here with these objects, and that's why they're called geometric solids. So you're going to have different shapes with them. Now, example 1 really is pretty straightforward. So notice that this figure is straight up and down. Okay, so it's just your typical volume. So we'll find the area of the base, and we're going to take that times the height. So let's see, they give us the area of the base. It's 34. Now when they say the length of a lateral edge, now lateral means it means the sides. So it says the length of the sides is 12 inches. The height of it is 12 inches. So all we're going to do is we're going to take 34 times 12. And if we do that, let's see, 34 times 12 would give us 408. And since it's volume, it's cubic inches. And that's my volume. So all we do with as long as the sides are straight up and down, as they will be in this section, you're just going to use your typical volume formula. Now, here's the one that is going to be a little new. It's going to be a little different. And as we read this, it says find the lateral surface area. Find the lateral surface area. Now, a while ago here, when we found, remember we talked about the lateral surface area, or the lateral, the side. So, for example, the area of the base times the area of the top plus the lateral surface area, if you remember that formula. So let's see, surface area is equal to the area of the base plus the area of the top plus LSA. And even though we're not going to use this today, it's tied in closely with this. LSA, how did we find the sides? So the area of the base is the area of the bottom, the area of the top was the area of the top, but how did we find the lateral surface area? And if you recall, that's the perimeter of the bottom, right? Times the what? Times the height. That was the sides. So to find the sides of an object, for example, if we went back to this box shape, if we're going to find the surface area, we find the area of the top plus the area of the bottom and then the sides. But to find the sides, we find the perimeter of the bottom times the height. And you know what? There really isn't anything new here. Okay, so to find the lateral surface area, it's this same formula, this thing right here. All right, so let's do this. So let's see the bottom. We're going to find the perimeter of the bottom. Now it looks like, and I'm going to have to, well, I guess I won't have to, but it looks like each side is 12. Right? It's a pentagon. It's a 5-sided figure. So let's see here. If I take 12 times 5, that's 60, right? So the perimeter of the bottom is 60. Now I'm going to take that times the height, right, of 16. And what do we get? So if we take 60 times 16, and we get 960. Now it's area, right? They want area. So what's my label here? It says dimensions are in feet, so it's square feet. That's my lateral surface area. So notice in this one, they did not want us to find volume. They actually wanted us to find the area of the sides. Now, here's something that I do want you to realize here on why this formula works for lateral surface area, LSA, perimeter of the bottom times the height. What would happen if I took this object and I cut it and I stretched it out? So in other words, notice here that I've got one side that's 12 by 16. I've got another side that's 12 by 16. I've got a side back here that's 12 by 16, right? I've got a side right in the back that's 12 by 16. And then finally, I have a side here that's 12 by 16. How many do I have? 1, 2, 3, 4, 5 of them, right? So if I cut this and I stretch this object out, I would actually have, let's see, 5 of them, right? 1, 2, 3, 4, 5. And each one, the bottoms of each one are 12, right? And the height is 16. So in other words, how would I find the area of this? How would I find the area of this whole shape? Well, it's a rectangle, right? So I would add these up, which is 60, and I take 60 times 16, right? Well, isn't that what we did when we found the perimeter of the bottom, which was 12 times 5, 60, and then we multiply it by the height of 16. So that's why that formula works to find the lateral surface area. All right, so again, our topic today was called geometric solids, very similar to some concepts that we've had before.